Angles. In this video, we want to talk about basic terminology of a trigonometric function. Since every function in trigonometry is about an angle, so first let's define angle. An angle consists of two rays or two line segments in a plane that have a common endpoint. So as you can see in this picture, we have two line segment or two ray. Ray means a line segment that has an arrow, has an endpoint, and the other side has an arrow. So you can see two ray that they have the same, or they have a common endpoint, which is called the vertex. It creates an angle from one ray to another ray. One ray is called the initial side of the angle, another ray is called the terminal side of an angle, and the direction from the initial to terminal side measures the angle. It's how we measure the angle. And we usually graph any angle in a standard position in this way. But the question is, how does that direction shows the angle? Because some angles are positive, some angles are negative. If the direction from initial side to terminal side is a counterclockwise direction, or this direction, we have a positive angle. But if we have a clockwise direction, which is this direction, we always have negative angles. And we usually show angles by using Greek letters like alpha, beta, gamma, phi, and theta. Quadrantal angles. What are quadrantal angles? Quadrantal angles are the angles whose the terminal side lies on an axis. It can be x-axis or it can be y-axis. So as the initial side in a standard position always is on the positive side of the x-axis. So the initial side is always, let me change the color. This is always the initial side. If we want to have positive angle, we have to move in counterclockwise direction. Now, if the terminal side, so this is the initial side, if the terminal side is along the positive side of the y-axis, we have a 90-degree angle. If the terminal side is along the negative side of the x-axis, we will have 180-degree angle. If the terminal side is along the negative side of the y-axis, we have a 270-degree angle. And if both of the initial and terminal side are along the positive side of the x-axis, we have either of 0-degree angle, or we can also have a 360-degree angle. So if initial and terminal both are on the x-axis or y-axis, we call those angles quadrantal angles. When we are finding the measure of an angle, we have two different measurements. We can measure by degrees or by radian. When we talk about an angle, sometimes we have an acute angle, which is an angle that's less than 90-degree angle, like 30 degree, 45 degree, 60 degree. They are all called acute angles. Sometimes we have a 90-degree angle, which is called right angle. Obtuse angle are the angles that are between 90 and 180 degree, like 120, 135, 150. And a straight angle is the angle that's exact 180 degree. When we are showing an angle with the degree, we have to use a degree notation, which is these small dots, we put it above the angle. So we say that's a 90-degree angle. We say 180-degree angle. This is the symbol for showing the degree. But sometimes we use a radian measurement. Radian measurement, it's based on the length of the arc that intercepted by an angle and the radius of the circle that the angle is. When we have an angle, which the vertex of the angle is the center of a circle. So you can see the angle here. That's the angle, which the vertex is exactly on the center of the circle. So on the circle, you see that a part of the circle is intercepted with this central angle, which we call it S. S is the length of that arc. So when we have 1 radian measure is when this arc length is exactly the same as the radius of the circle. If these two are the same, we have 1 radian measure. Otherwise, we always, to find other radian measurement, we need to divide S by R. If S and R, they are the same, so they can, like 2 and 2, 1 and 1, 3 and 3, they cancel each other, so we have 1 radian. Otherwise, we need to divide the arc length by the radius of the circle to see how many radian is that angle. And if you look at the circle, you will see that the 90-degree angle, since it's a quarter of a full rotation, is pi over 2. Why? Because half rotation or half revolution is 180 degree. This is the half revolution. That's 180, which is equal to pi. That means two half rotation or a full rotation or a full revolution, which is 360, is called 2 pi. Half of the pi is pi over 2, and this point, which is 3 pi over 2, because we always, the coordinate plane always divide the whole circle into 4 quadrants. So we have a first quadrant, second, third, and fourth quadrant. And every quadrant has a 90-degree or pi over 2. So when we are on the first quadrant, that means we have a pi over 2 or 90-degree. Second quadrant, that means 290-degree, which is 180. Third quadrant, which is 390-degree, or which is 180, or 3 pi over 2. And fourth quadrant, for a full revolution, we have 490-degree, which is 360, or 2 pi. Okay? Let's look at an example. It says a central angle data in a circle of radius 12 feet intercepts an arc of 42 feet length. What's the radian measure of data? We have a central angle, which means the vertex of the angle is on the center of the circle. The radius of the circle is 12 feet, so we show the radius by R. And so if we have a circle, we have a central angle, the radius is 12, and this angle intercepts an arc of 42 feet length. Okay, I don't know the angle, but if the angle is over here, the arc, the intercepted arc is 42, which is this. Okay, now we want to find the radian measure of data. The radian measure or data is based on the arc length and the radius. And we know it's always equal to S over R. S is 42 feet, R is 12 feet, and if we divide 42 by 12, we get 3.5. So that angle is 3.5 radian. We don't have any notation for radian. You can just write the word radian or just use the word just RAD. showing as a radian. But if it's degree, you can just use this notation, that a small circle above the number. Now the question is, how we can convert degrees to radian or degree radians to degree? We know that pi radian is 180 degree. We know that 2 pi radian is 360 degree. But what about the other angles? What about 30 degree? What about 60 degree? How we can convert it to radian, or how we can convert a radian to degree? To convert from degree to radian, we need to multiply it by pi over 180. And to convert radian to degree, we multiply by 180 divided by pi. So degree to radian is pi over 180 multiplied by this. For radian to degree, multiply by 180 divided by pi. And then simplify and see what angle do we get. Let's look at an example. We want to convert from degree to radian. From degree to radian, we need to multiply by pi over 180. When we multiply a number by fraction, we need to make sure that that number is also in fraction form. If there is no denominator, you can give it a denominator of 1, and then start simplifying. Start simplifying 135 by 180. Or you can multiply across first and then simplify. If I multiply across first, I can multiply 135 by pi, 1 times 180, which is 1/8. Now I can simplify 135 and 180, divide both of them by 5 first. 135 divided by 5 is 27. 180 divided by 5 is 36. I see that 27 and 36 still can be simplified and divided by 9. And if I divide 27 by 9, it gives me 3. Divide 36 by 9 gives me 4. So 135 degree is 3 pi over 4. Next part, negative 68 degree. Again, we have a degree. We want to convert it to radian, so multiply by pi over 180. Multiply across, so keep the negative. We have 68 pi over 180. Start simplifying 68 and 180. I know that we can divide both by 2. And we may be able to divide by 4 as well. Let's see. If I divide 68 by 4, I will get 17 pi. And if I divide 180 by 4, we get 45. And then we cannot simplify more. And don't forget that we have to keep the pi. We have to leave the pi, because when we have a radian measure, it has to have a pi included. So we're not replacing anything for pi. Just keep the pi, just simplify the number. Now, for example 3, we want to convert from radian to degree. We have 3 pi over 2 radian. To convert from radian to degree, we need to multiply by 180 over pi. I can multiply across, or I can simplify first, then multiply across. I can simplify 2 by 180, 2 divided by 2, 180 divided by 2, and I can also cancel pi by pi, because one is on top, one is at the bottom. Now I can multiply across the remainings, which is 3 times 90, and it's 270 degrees. So 3 pi over 2 radian, it's 270 degrees. 7 radian. How we can convert 7 radian to degree? Even this radian measure doesn't have any pi, still we need to multiply 7 by 180 over pi. Usually most of the radian measure have pi. And when you multiply it by 180 over pi, pi and pi cancel each other, because when we are converting to degree, we don't want any pi. Okay, but if the number, like example B, doesn't have pi, When you multiply by 180 over pi, pi cannot be canceled. You can just multiply across. There's nothing that you can simplify. And if you multiply 7 by 180, you will get 1260 over pi. But I'm not going to leave numbers with pi in terms of pi when I am converting to degree. So now what do? We replace the pi by 3.14 or use the pi key in the calculator and just divide 1260 by using the pi key in the calculator. So 1260 divided by pi. Which is 401.27 degree. Okay. So for some angles, it's good that if you can memorize the radian angles and remember that conversion, because 30-degree angle is always pi over 6. 45-degree in radian is always pi over 4. 60-degree is always pi over 3. Or 120 degrees, 2 pi over 3. So if you remember some of them, that helps you a lot. Or even just if you can memorize that these three, pi over 6, which is 30 degree, pi over 4, which is 45 degree, pi over 3, which is 60 degree. And remember that any other number that has the denominator of 6, it's a multiple of 30 degree. If you see a denominator of 4, that's a multiple of 45 degree. And if you see a denominator of 3, that means that's a multiple of 60. For example, when they ask me 3 pi over 4, I know that pi over 4 is 45 degree. So 3 times 45 is 135. So it's easier to find the measures instead of just multiplying, simplify the fraction, we can find it, convert it faster. And since the denominator was 4, I knew that should be a multiple of 45 degree. That should be an angle that has a 5 or 0 at the end. Or when they ask me what is 7 pi over 6, because of the 6 on the denominator, I know that should be a multiple of 30 degree. Okay, and you know pi over 6 is 30 degree. So what is 7 times 30 is 210. That's much easier if you just remember these three. You know the both radian and degree measurement of these three angles. Coterminal angles. Coterminal angles are the angles that they have same initial and same terminal sign. So imagine that you have this angle. This is the initial side. And this is the terminal. If I can find another angle that starts with the same initial and end at the same terminal side, that angle would be the coterminal angle with this angle. If this angle is called alpha, I can find another angle that is a coterminal with this angle. And we can start with the same initial, pass one full rotation, and then get back to the same terminal side. And this angle, which is past the one rotation, it is a coterminal angle with my angle. So usually you can find, through the rotation, you can find as many coterminal angle for each angle. Because after every one rotation, you can get a new angle that's coterminal with the same angle, the first angle. After second rotation, you get another angle, which is coterminal. After third rotation, fourth rotation. So you can find infinitely many coterminal angles. You can also find some coterminal angles in a negative direction. If this is the initial side and that's the terminal side, I can start from initial getting back to terminal. So this is also another coterminal angle for alpha, but in negative. Usually when they ask us to find coterminal, we can find negatives and positive angle. Depends what the question is asking. If they ask you to find positives, we only have to find positives. Negatives, you just need negative one. Let's look at this example. It says sketch each angle in a standard position and then draw an arrow to represent the amount of rotation. Then find an angle which is between 0 and 360. It means in the first rotation that is coterminal with this angle. Okay, so let's graph the angle in a standard position first. I always start with this line, which is my initial. Okay. And if I go and get to this line again, I have 360 degree. Okay, but my angle is 870 degree. So I have to keep going, keep going, keep going, keep going. In the second rotation, I just get to 720. So because 360 plus 360 is 720. But to get to 870, I need 150 degree more. So after the first rotation, I need 150 more. And I know that 150 is in the second quadrant. So now I can graph the angle, graph the terminal side. And by having an arrow, I'm showing the direction of the angle and showing how many rotation I need to pass. So I graphed 870 in a standard position. Now I want to find the coterminal angle. Coterminal angle is an angle with the same initial and same terminal. I'm going to start with the same initial and end at the same terminal. That's it. So this blue one is a coterminal angle with the red one. And this blue angle is 150 degree. So 150 degree is the coterminal, is alpha, which is the coterminal angle with 870 degree. Let's graph negative 300 degree. So negative 300 degrees, so in a negative direction I have to move. And I always start with the same initial. Okay. 300, that's one position, 60. But and it's 300. That means it's 60 less than one full rotation. So that means I can stop here. And by putting that arrow, I'm showing the direction, which is negative direction. So this is the negative 300 degree. And this is my initial side. That's the terminal side. Now, to find coterminal angle, I'm going to use same initial and same terminal, but in a positive direction. So this is alpha, which is the coterminal angle with negative 300 degree angle, and this angle is 60 degree. So 60 degree angle is a coterminal angle with negative 300 degree angle. Reference angle. Reference angle are the angles that made by the terminal side and the x-axis. So made by the terminal side of angle and the x-axis. And it's very important angle because especially for large angles, if we know the terminal, we know the reference angle, which is always an acute angle, which is important that you remember that reference angle is always acute angle. That means it's less than 90 degree angle. Okay. And it's always positive. If you can find the reference angle, every trigonometric function that you need for your angle, that should be the same as the reference. okay? So something that you need to remember, that reference angle is always acute angle, and it's always between the terminal side and the x-axis. If we have an angle in the first quadrant, like this angle, so the reference angle is between the terminal side and the x-axis. So that's exactly the same as the angle. For all the angles in the first quadrant, the reference angle is the same as the actual angle. If we have an angle in the second quadrant, this one, reference angle is between the terminal side and the x-axis, which is this angle. If we have an angle in the third quadrant, the reference angle is between the terminal side and the x-axis, which is this angle. If we have an angle in the fourth quadrant, or this angle, reference angle is between the terminal side and the x-axis, which is this angle. And since reference angle is always positive angle, it's always in a counterclockwise direction. Let's look at example 5. We want to graph each angle and find the reference angle for each of them. First, I want to graph the angle in a standard position. That helps a lot to find the reference angle. 170, I know that 0 is here, 90 degree, 180 degree, 270 degree angle, and 360 degree. When I have a 170 degree angle, that means it's in the second quadrant, somewhere over here. This is a 170 degree angle. Again, we never forget that the initial side is always this side. That's the positive side of x-axis. Now, I graph my angle, but what is the reference angle? Reference angle is between the terminal side and the x-axis, which is this one. This is the reference angle, which is 10 degrees. Let's graph other angle. Negative 300 degree. Negative 300 in the negative direction. We have to go for 300, which is in the fourth quadrant in the negative direction. And that's the angle. This is a negative 300 degree. Now, to find the reference angle, I need an angle to show an angle between the terminal side and the x-axis, which is this angle. And this angle is a 60 degree angle. So the reference angle is 60 degree angle. That means later when we learn about the trigonometric function sine, cosine, so the sine cosine of 300 degrees is the same as a 60 degree. Next one, 5 pi over 4. So let's graph the angle first. 5 pi over 4. This time we have a radian measure. And in radian, I know this is a 0 radian, pi over 2, which is 90, pi, 3 pi over 2, and 2 pi. These are the radian measure. So as you see, we have pi over 4. That means pi over 4 is 45 degrees, right? That means we have a multiple of 45 degree angle. 45 degree angle is half of the 90 degree. That means if I have a line that's dividing each quadrant into two equal angles, each of them is 45 degree or pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. So this is a 5 pi over 4. Or if it's hard for you to understand where is 5 pi over 4, you can convert it to degree. That gives you an idea which quadrant the angle is. Because if you multiply 45 by 5, you will get, let me see, So 45 times 5 gives you 225, which means more than 180. So it's in the third quadrant. Now, to find the reference angle, I need to show an angle between the terminal side and the x-axis. So this is the reference angle, which is exactly 45 degrees for pi over 4. So that's the reference angle. And last part, we want to graph negative 7 pi over 6. So let me graph the angle first. Negative 7 pi, so it's in a negative direction. 7 pi over 6. Pi over 6 is a 30-degree angle. You can multiply negative 7 by 30, which is negative 210. Or you can say that is a multiple of 30 degree. 30 degree means each quadrant must be divided into 3 equal sections. If I divide each quadrant into 3 equal angles, now I'm going to start in a negative direction and show negative 7. So 1, 2, 3, 4, 5, 6, 7. So that is the terminal side. So this is negative 7 pi over 6. Now, to find the reference angle, I need to find an angle between the terminal side and the x-axis, which is this one. So this angle is just 1 pi over 6 or 30-degree angle. When we talk about the radian measure, we said that a radian measurement is coming by dividing the length of the arc that's intercepted by the angle theta, and then divided by the radius of the circle. So we said that theta is always equal to S over R. Now, if they ask us to find the arc length of a circle, also we are using the same formula, but since we want to find the arc length, that means we want to find the S. And if you isolate the S from that formula, so you want to find the S from this formula, you can give it a denominator of 1 and do the cross multiplying. And you will see that 1 times S, which is S, must be equal to R times theta, which is R theta. So you can use this formula that's coming exactly from the previous formula to find the arc length of a circle. But something that's important that you know that the theta or the angle must be always in a radian. That means if it's in degree, you have to convert it to radian first. You're not going to use any degree angle in this formula. First example, it says a circle with radius 5 meters that is intercepted by an angle which is measuring 3 pi over 8. We want to find the arc length. We want to find the S. If you want to find the S, we need to know the R and the theta. R is the radius which is 5. Theta is an angle in the radian measurement, and it's 3 pi over 8. And if I multiply across, I will get 15 pi over 8. And if you want to exact measure of the arc length, you can use the pi key in your calculator. So you just type in your calculator and you say 15 times pi and then divided by 8, which is 5.89 meter. That's the arc length, if you round it to 2 decimal digits. Next example, it says a circle with radius 8 feet that's intercepted by an angle measuring 210. Again, you want to find the arc length. You want to find the S, which is R times theta. What is R? What's the radius? It's 8 feet. What is theta? It's 210, but that's a degree. We need data in radian. So we have to convert 210 to radian first by multiplying pi over 180. You can cancel 0 with 0. 21 and 18. 21 divided by 3 is 7. 18 divided by 3 is 6. So the answer is 7 pi over 6. Now we are going to use 7 pi over 6 in the formula. Multiply across or simplify before multiply across. When we want to simplify, we need to have common factors in the top and the bottom. 6 divided by 2, 8 divided by 2. No more common factors. Multiply across. 4 times 7 is 28 pi. 1 times 3 is just 3. Again, since we are finding the arc length, we don't want to just keep it in pi because we don't have any idea how much is the arc length. So now we're using the pi cubic calculator. 28 times pi divided by 3. So the answer is 29.32. This time the unit is feet because the radius was in feet. Area of a sector. If we have a sector of a circle, so we have a circle, it has a central angle, which this arc length is S, the radius is R, and the angle is theta. If they ask us to find the area of this sector is a portion of the circle. If we want to find the area of this portion, we're going to use the formula. We want to find the portion of the circle multiplied by the area of the whole circle. The portion multiplied by the area of the whole circle. So it gives us this formula, 1/2 r squared times theta. So to find the area of a sector, we need the radius and the angle theta. Again, we need to make sure that the angle is in radian when we're replacing into the formula. We want to find the area of the sector. Okay, one sector is shaded in blue, and we want to find the area of that sector. So to find the area of a sector, we need to have the radius and the angle. The radius of the circle, which is this, is 18. We just replace the r by 18. Theta, or the angle, is 210, but we need it in radian. So we convert 210 to radian first. We did it here, which is 7 pi over 6. Now we just replace it here and try to simplify this one. Based on following PEMDAS, we have to find 18s squared first. 18 times 18 is 324. If there is no denominator when you're working with fraction, you can just leave the denominator of 1. And we need to now do the multiplication and multiply these 3 fractions. And we know that before multiplying, we can simplify. I can simplify 324 by 2. And if I divide 324 by 2, it gives me 162. 2 divided by 2 is 1. I can also simplify 162 by 6 and divide it by another. Let me see if it's divisible. 162 divided by 6 is 27. Okay, 6 divided by 6 is 1. 162 divided by 6 is 27. Nothing else is left on the bottom, so that we have to just multiply the top. 27 times 7 pi, which is 189 pi. This is the area of the sector. But again, to understand the measure of area, if we don't want to convert it and not keeping in terms of pi, we need to use the pi key in the calculator, and 189 times pi is 593.76. There is no unit in this picture, but that should have the same unit with the radius in a square form. Next example, it says a car with a single windshield wiper has an arm and blade that is 10 inches long and rotates back and forth through an angle of 95 degrees. The area claimed by the wiper blade that is 7 inches long is shown as the shaded region. Find the area of the region claimed rounded to the nearest 10. That means we want to find the area of this sector, but only the shaded area, which is this part. We just want to find this area, not the whole. Okay. But the formula that we have for finding the area of a sector, it's for the whole sector. So if I use 10 inches as the radius, it gives me the area of the whole circle. That means the whole part. But if you want to only have the area of the shaded part, you have to exclude that not shaded part. So that means this part in green must be excluded. So as you see in the picture, we have one whole shaded area for the red part, one whole shaded area for the green part. So the radius of the green part is 3. And to find the area of the shaded region, we need to find those two areas and then subtract from each other, because we need to exclude that part, the green part, from the red part. So let's find the area for the whole, area for the green part. So using the same formula, area of the sector, and we know that the radius is 3 and the angle is 95 degrees, but degree must be converted to radian. And if we convert 95 degrees to radian, we will get 19 pi over 36. Okay. Sure. Okay. And we replace it here. 3 squared is just 9, so we have 1/2, 9 over 1, 19 pi over 36. We can simplify 9 by 36 and then multiply across, so we get 19 pi over 8. That is the area of the green part, since the radius is 3 for that part. Now, we need to find the area for the red part, and we know that the radius for that part is 10. But still we have the same angle. And we know 10 squared is 100. We can simplify 100 with 36 and 2. Simplify 2 by, divide by 2, 100 divide by 2, 50 divide by 2, 36 divide by 2. Now we get 25 times 19 pi, which is 475 pi over 18. That's the whole and red shaded area. But if you want to find the blue shaded region, the area for the blue shaded region, you need to subtract them from each other. So you need to subtract 475 pi over 18 by 19 pi over 8. So after finding the common denominator, the common denominator between 18 and 8 is 72. And then we get 1729 pi. So that is the final answer. But if you don't want to keep it in terms of pi, you need to use the pi key and you will get 75.4. Since the radius is inch in inch, so it's inch squared, because that's, we are talking about the area, and area is always in the square term of the unit. So if the radius is 7 inches, the area is 75 inches, square inches.